Okay, arc lengths and quadrantals constraints. Part 1, arc lengths. I know I've not gone over homework yet, but how was it?
It was just long.
What was that?
It was just long.
The notes? Oh, the homework was just long?
Yeah.
Okay. But not hard?
No.
Okay. Do you think that meant that many problems was necessary?
No.
Or could you have gotten enough practice with less amount?
This amount would have been fine.
Would have been enough?
Not just because, like, I don't know, I wanted to tell me, but, like, legitimately.
It was like overkill?
Yeah.
Okay. All right. Theta. Do you guys remember doing arc length in Math 2? Kind of? Okay. Arc length is a fraction of your circumference, like this piece here. Now we find it a little different than we used to in Math 2, but think of it as, we've talked about this before, if this circle was made out of, we can't get a ruler and measure around the circle, but if this circle is made out of like string and I snipped it at one of the piece here, laid it out, could I measure it with the ruler? Yes, that's the circumference. Well, this is just a piece, so if I snipped here and here and measured just that piece, that is the arc length. So when you did this back in Math 2, you used a fraction of the circumference because that is what it is. But we're doing it different here. S represents the arc length. So when we write our formula down in just a bit, S is going to represent the arc length. R will represent the radius. And what is theta representing? The angle measure. Now I will tell you this, that theta is always in radians, and yes, it's important that you know that. Theta is always in radians. So if it's not in radians and you're asked to calculate, what do you have to do first to your angle? Change it. Convert from degrees to radians. All right. Excuse me. The formula is this. S, the arc length, equals your angle times your radius. S equals theta times R. S equals theta times R. Think of it as we are eagles. We soar like an eagle. Can't spell, but we can soar. Soar. So that's one way to remember it. S equals theta R. Without looking at your notes, what is it?
S equals theta R.
S equals theta R. Okay. Questions here before we do our examples. All right, number 1. Find the angle in radians. Okay. I'm looking for theta. What does the 4 represent in this picture? This is 4 here. What is that representing? The radius or the arc length? Arc length, okay. And then 3 is representing the what? The radius. So you plug it into your formula. S, which is 4. Well, let's write the formula down first. Theta R. S is 4. Theta we're looking for. And R is 3. What do I do with the 3 to solve for theta? Divide it. Got to divide by 3, divide by 3. And what does theta equal? 4 over 3. And it is radians. I'm going to write it, at least the rad or uppercase R is up to you. Because it's not as obvious. Like 4 pi over 3, sometimes that, you guys can leave the radians off there, but this one's not as obvious, so do write it 4/3 radians. And again, this is not 4 pi over 3, it's 4/3 of a radian. So 1 1/3 of a radian. All right, questions on number 1. Number 2. Okay, theta is the bigger angle on the back side, on the outside, not this little tiny one in here. Your radius is 6 centimeters. It's kind of sloppy. Six centimeters, and then your arc length, this big piece back here, is 24 centimeters. Go ahead and plug it in. What'd you get?
They were like giving out free ones because like they like stopped selling for it.
Were they selling them out there?
Yeah, gotta go help Auto Club like take everything down.
How did your pancakes come out?
Very good. Yeah, we got a lot of people. They taste great.
Thank you.
So what have we been doing?
Starting notes.
Cool. Am I that far behind it?
These 3 or 2.
Oh, that's it.
Yeah.
All right, cool.
All right. So did you guys get it done? S equals theta r. What did you plug in for S? 24. What do you plug in for theta? We don't know. And what do you plug in for r? And then we divide both sides by 6. What does theta equal? Theta equals what? 4 radians. Questions? Make sense? Yes? All right. Number...
This is 3.7.
This is 3.7. Number 3. Find the angle in degrees for a circle with a 6-inch radius and an arc of 5 pi inches.
Oh, would you mind putting the paper?
Mm-hmm. So I'm going to have you guys do this one on your own. I'm going to have you try this one on your own. Work it out. different? All right. Looks like I couldn't trick any of you guys, huh? All right, did any of you draw a picture, yes or no? Yes? Did anybody do without a picture? Good, okay, it's your choice. Find the angle in degrees for a circle with a 6-inch radius and an arc of 5 pi inches. Yes? All right, say theta S equals theta R. S is 5 pi. What is theta, or is that what we're looking for? Looking for times the radius, which is 6. Divide both sides by what? Theta equals 5 pi over 6. Did anybody stop here initially? Yeah? Did anybody get help from a friend or figure it out on their own, like, oh, this is wrong? Yep. Okay, who can tell me why this is wrong? Because it asked for degrees. I will tell you this, kids get stumped on this one every year on the test, so please don't be that one that doesn't notice this here. If you didn't get it the first time, well, you did on your own, if you marked this initially before you realized, oh wait, I messed up, put a note to yourself, study this for the test. Make sure you look out for this one and do not let it trick you. All right, you convert or you have memorized. Does anybody have memorized that 5 pi over 6 is 150? Anybody have that one memorized? Some of you do. If you don't have it memorized, do you guys remember how to convert? 5 pi over 6 times, I'm trying to change it to a degree. So 180 is at the top and pi radians is at the bottom. And since this is a radian and that's a radian, will the pi and the radian reduce? Yes, remember the pi's don't always reduce. The radians will, the pi's won't always happen. All right, 6 and 180 reduce. 6 becomes 1, 180 becomes 30. And then 5 times 30 is 150. So theta equals 150 degrees. Make sense? Did anybody do this one and it didn't stump you at all? Like you got this and you knew right away to change it? A few of you were like, yeah, I got it. Okay. Number 4. Yes, let me write down number 4, then I'll show you. Number 4, find R. S equals 26 feet and theta equals 90 degrees. All right, I want you guys doing that one right now. Okay. Did you guys get answers? What did you get? Yes.
I got 0.289 feet.
0.289. Anyone else? That or a fraction?
I got 13 over 35.
13 over 45. Anyone else get 13 over 45? Anyone else get something different? No comments? All right, let's see what happens on this one. Same formula, SOAR, S equals theta R. S, we plug in 26. What do we plug in for theta? 90. And what are we looking for? For the radius. And so we divide both sides by 90 by 90. And is this what you guys reduced when you got the fraction?
Yeah.
And what did it reduce to? 13 over 45. And what was the decimal? 0 point what? 289. And nobody's going to stop me? No one's going to say, hey, wait a minute, Mrs. Torres, you've done something wrong. Yes, either one of you guys.
Theta has to be in radians.
Good job. Theta has to be in radians. Now, remember I said that earlier, and I said you have to know this, you need to know it. I'm going to go back right here. Theta has to be in radians. When you're using this formula and you're plugging theta in, theta has to be a radian. When you're using this formula and you're solving for theta, theta comes out as a radian. Does that make sense? So if you're looking for a degree, you have to convert your answer at the end. If they give you a degree that you have to plug in, is it safe to plug the 90 in? No, it is not. So you see that? So put a star by this one, study it, make sure you know it. So what's the proper way of setting it up? S equals, what is 90 degrees? Pi over 2. S equals pi over 2 times R. And I'm going to erase the S. What would I put there? 26. And if I'm looking for R, I divide by pi over 2, but that's equivalent to multiplying by what? 2 over pi. Okay, so I don't think anybody had this originally because nobody stopped me, so you're fixing it now. Did you have it originally? And you just didn't want to stop me? All right. What's 2 times 26?
52.
52 over pi equals R. We're going to change the pi to what? So we can plug it in our calculators. 3.14. Does anybody have a calculator out? Round to the nearest tenths. Oh, hundredths. Let's do hundredths. Can you share?
It's 16.56.
Thank you. And it is in feet. Okay. Make sense? Okay. Questions before I move on to quadrant constraints? Okay. State the quadrant. State the quadrant theta is in. State the quadrant theta is in. Number 1. Now I'm only going to give you half of the information that I'm supposed to give you. I will tell you that sine of theta is less than 0. comma, oh, nope, and I'm not going to give you the second piece of information yet. With just this information, I want us to use our all students take calculus. If sine is negative, what two quadrants could I possibly be in? I'm going to repeat the question. Do you agree that sine of theta is less than 0 means it's negative?
Yes.
Okay, which two quadrants could I be in?
3 and 4.
3 or 4. Why is there no way that I could be in quadrants 1 or 2?
Because y is positive.
Because that's where all are positive and the y sign value is positive, right? Okay. Now, right now this leaves me with two answers. It doesn't say quadrants, it's singular, quadrant. So I need only one answer. That's where this next piece of information comes in. So I'm going to write it down. I will give you that cosine of theta is greater than 0. Do not blurt it out. Think about it. Try it on your own and see if you can come up with which quadrant you are in. Bless you. Not yet. All right. So you're thinking you're done with this, right?
Yeah.
Okay. Justin, give us the answer.
I think it is C, calculus, that quadrant, so.
The C, the calculus quadrant 4. Do you guys agree with him?
Yes.
Okay. Can you explain why?
So, since cosine is greater than 0, it must mean that it is positive. And in that quadrant, cosine is always positive.
Good job. And now why couldn't, so it can't be here because cosine's negative here. Why couldn't it be quadrant 1? In quadrant 1, cosine's positive.
Because sine needs to be negative.
Good job. Because sine needs to be negative. So this is the only quadrant where sine is negative and cosine is positive. Make sense? All right. Number 2. Cosecant theta is greater than 0 and cotangent theta is less than 0. Now before we make our all students take calculus, we don't, well, let me do it. Do we have like a little saying or acronym for cosecant or cotangent? No. But what do we know about reciprocals? The reciprocal of a positive number stays positive, and the reciprocal of a negative stays negative. So cosecant's the reciprocal of what?
Sine.
Sine. So if cosecant's greater than 0, that means we're thinking, oh, sine will also be greater than 0. Does that make sense? Yep. And cotangent's the reciprocal of what? Tangent. So which means tangent must be negative. So I'm going to have you try that now. Don't blurt out the answer. You're trying it on your own. Eliminate and see where you end up. Mohammed, can you tell us what quadrant we are in?
Second one?
Second one. Do you guys agree with him?
Yeah.
Yes. Allison, can you explain why we're in the second quadrant?
Sine is positive.
So if sine is positive, we can't be in these bottom two, correct? Okay, keep going.
And then tangent is negative. So
And-
it'd be negative.
Right, because here everything's positive. All right, make sense? All right, good job, guys. Any questions on this piece, or does it seem doable?
Can you go over the tangent thing again?
The tangent thing, the piece I have here in the bubble, or just what she said about which quadrant you're in?
Just which quadrant?
Okay, yes. So we started off, you got what she said first about sine being positive, correct?
Yeah.
All students take calculus. Sine is positive in these top two, so there's no way we're down here.
Mm-hmm.
And she said tangent needs to be negative, and here all are positive and only sine is positive. So we can't be in quadrant 1 because tangent needs to be negative and everything's positive in quadrant 1. which leaves us with quadrant 2 where only sine is positive.
Okay.
So sine is positive and tangent is negative.
Thank you.
All right. Questions before I move on? Okay. Find the 6 trig functions given tan of theta equals negative 12 over 5 comma blank. Now, I'm not going to give you the blank yet. I do want to talk about this problem just a little bit before we get started. So I'm giving everyone a chance to write it down. Okay. Everybody have it? Now, do you remember a few days back, this was the 25th, I said given cosecant of theta is 10/6, find the 6 trig functions. And I told you then it doesn't matter how you draw your triangle. Your right angle can be up here, over there, over here, blah, 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 as long as when you do it and you put theta in whatever corner you put it in, that 10 is the hypotenuse and 6 is opposite to your theta. Do you guys remember that? And I said eventually we'll get to the point like these here where you have to draw it in a correct spot, where earlier it did not matter. Yes? Okay, so we are now officially at the point where it does matter. So you cannot just randomly draw this one anywhere you want, like we did on that one previous problem. So I want to quickly go over with you what we just did. We have to eliminate. If tangent is negative, which 2 quadrants can I cross out?
Looks like it's
The A, because they're all positive, and the T because tangent's positive, and we want tangent to be negative. Do we have enough to say the triangle I'm going to draw is in quadrant 2? Not yet. So that's where this extra information needs to be given. So sine of theta is less than 0. With that given information, I want you to figure out which quadrant you are in. Yes?
So are you doing this so that you're trying to have us think critically only halfway through the question?
Yes.
Okay.
That is exactly why. On the homework, they're not going to do this. They're not going to like hold off and then like you have to figure this out or underline it. It's just going to be this and this. But I do want you to think critically first, like, okay, do I need more information? And realize, yes, you do. You need these 2 pieces. There will be a handful that just flat out tell you, you're in quadrant 2. You're in quadrant 4. Some of those will do that, but there will be some like this where they give you 2 pieces of information and you have to eliminate. Which quadrant are we in? 4, because that's the only one where tangent is negative and sine is negative, because sine is positive there. All right, so what we're going to do in this space here is actually draw our coordinate plane, our x and y axis. All right, and what quadrant did we say? 4? Yes? Okay, so I draw my point there, my terminal side coming out of the origin, and does this look even remotely correct? No. It should just look funky and weird and awkward. We never draw them to the y-axis. We always do what? X, up or down to the x-axis. And theta's always in this corner, so we put theta here. And in words, what is tangent? What over what? Say it again. Y over x, or opposite over adjacent, however you think about it. If you're doing y over x, this is y and this is x. Opposite over adjacent, that's opposite, this is adjacent. Do you agree? All right, so what would I put right here on this side here? 5. And ignore the negative for now. What would I put here? 12. Now, do not assume that just because the negative is attached to the 12, that's where the negative would go. Because do you agree, I could write it like this if I wanted. That negative technically could go the top or the bottom. we typically write it at the top. So don't assume that just because the 12 is negative, that's where the negative goes. It does in this case, but it will not always happen. But do you see the 12, it's what's negative, and the 5 is positive? Now again, is a 12 negative because it's negative up here? No, it's negative because that's the one that's going downward in the negative direction. Now I heard some of you already give me the hypotenuse. Do you guys have the triple memorized from last year? 5 squared plus negative 12 squared equals c squared. What does c equal? 13. If you didn't know that, then you do the math. 25 plus 144 equals c squared. Add in square root. All right. Do we now have enough information to find sine of theta, cosine of theta, and tan of theta? Yep. Sine is opposite over adjacent, so go ahead and find that now. And did I say opposite over adjacent?
Yeah.
I apologize. I did that in my last class. I don't know why. Opposite over what? Hypotenuse. So opposite over 13. Can I reduce? No. Cosine is adjacent over hypotenuse, so what fraction would that give us?
5 over
13. And still can't reduce. And tangent's opposite over adjacent, the one I said earlier. And what's opposite over adjacent? Now, do you guys remember what the reciprocal of sine is?
cosecant.
Cosecant. Are you guys using that trick I've given you guys? What's the reciprocal of cosine? Secant. And the reciprocal of tan? Cotangent. All right. And when I reciprocal them, I leave the negative at the top. You can put at the bottom. I just don't like to. Now, you do have questions like this on the test, so you want to make sure that you understand what is going on. Any questions on this one before we move on? Yes.
This might sound like a dumb question, but on the graph, why is 13 positive?
Very good question. What have I said about the hypotenuse? It's always going to be positive. The hypotenuse will always be positive, regardless of which quadrant you're in. When you're doing these type of problems, your hypotenuse is always positive. Always. Think of it as the radius of your circle, and it's always positive. All right? Questions before we move on?
You just
Yeah.
so with the negative fractions, when you flip them, they'll always stay negative.
Yes. The reciprocal of a positive stays positive, and the reciprocal of a negative stays negative. I just moved the negative to the top, to the numerator. What quadrant are we in here? 4th? What's the only thing positive in quadrant 4?
This is cosine.
And is that true according to our data? Cosine and its reciprocal. And then sine and tangent and their reciprocals are negative. Yep. And then you can compare over here as well, that did come out. Questions on this, yes or no? Doable? Okay. Last piece, part 3. Find the missing angles. Find the missing angles. Find 2 solutions give solutions in degrees, parentheses, leave enough room in there, we're going to write something in there, and radians. Everybody have that down? I'm going to flip the page really quick. If you don't have it down, it's okay. I'm going to put it back. Do you remember when we did these? This was the 26th. Sine of what angle is root 3 over 2, and we got pi over 3, or 60 degrees. Do you guys remember when we did this? And we said, oh, so when is sine root 3 over 2? And we looked over here, and it was right here at 60 degrees. Yes? And what was our constraint here? We were only in quadrant 1, between 0 and 90. Do you see that? Now that we've done all 4 quadrants, we are opening it up to all 4 quadrants. So now how many answers would I end up with? 2. Because there's 2 places where sine is positive and 2 places where sine is negative. There's 2 places for cosine where it's positive, negative, and the same for tangent. Make sense?
So, real quick, you're saying that because is it just something we did after this?
So for example, let me show you the right here we were only in quadrant 1. Right now we're about to be in all 4 quadrants. So when is sine root 3 over 2? Sine is the y value. Can you see it's positive root 3 over 2 there, but it's also positive root 3 over 2 there. So we'd end up with 2 answers, 120 degrees and 60 degrees. Tangent is 1. Tangent is 1 here, but it's also 1 over here. A negative over negative is positive, and a positive over positive. So now you're going to have, you're opening yourself up to more answers. Got it?
Yeah.
Okay. And eventually we restrict ourselves back down to 1 answer in units to come. All right, so degrees, since we're in all 4 quadrants, we would say that 0 degrees is less than or equal to theta, and theta is less than what? All 4 quadrants, I'd go all the way around to 360 degrees. Should I have any negative answers? No, because theta is between positives, or 0 and positive 360. Should I have an answer that's like 380? No, between 0 and 360. Can I have an answer that is 360?
Yeah.
Ooh, that is another no. Why not?
It's not equal to.
There's no equal bar. Ooh, I'm glad you said that. Okay, so if I cannot equal 360, and I'm at 360, what would I put as my answer instead?
0.
0, because they're coterminal, correct? So if you're at the 360 and you're like, oh, 360 is my answer, and you mark it, will I mark it wrong? I would. It has to be 0. Okay, 0 radians is less than or equal to theta, and theta is less than, what's 360 in radians?
2 pi.
2 pi. All right. So again, not equal to the 2 pi. So if you're at your 2 pi mark, you mark 0 instead. All right, we're ready? Mm-hmm.
What I'm not understanding is you're finding solutions for the same
Radian?
it's back here somewhere. The quadrantal.
Yes.
So you're finding
The quadrants?
2 solutions for each measure of the quadrantal.
Yes. For the quadrant. Yes.
Okay.
All right. So let's start off. Now, how many of you guys use this when you were doing your worksheet? The last worksheets that we had? A few of you? How many of you were doing the hand trick that we went over? A few of you. Okay, so it's up to you and how you do these, whatever works best for you. I will show you both ways. Sine of theta equals positive root 3 over 2. Now, when you're doing these on your own, you will be doing more of this in your head, but this is what you're doing in your head. So this is you thinking. You're like, which 2 quadrants is sine positive in?
2, 1, and 2.
1 and 2. All right. So then you look for your reference angle. So I'm going to use my hand trick first. Sine is x or y?
Y.
Y. So that means this one would have to be down if I want root 3 over 2, correct? And what finger was this? This was 30, 45, and
60.
60. So 60 degrees in quadrant 1 and 60 degrees in quadrant 2. Quadrant 1's pretty easy. What is 60 degrees in quadrant 1?
60.
60 degrees. Anybody have it memorized or can figure out if this is 180, what is 60 degrees in quadrant 2? 120. Now, is that pretty easy? Yes? If you don't like the hand trick, then we're not done because I still need radians. But if you don't like the hand trick, then you look here. When is y root 3 over 2 positive? So 60 and 120. Do you see that? If you look down here, it's negative root 3 over 2 and negative root 3 over 2, so it's not going to work. All right. Oh, what are they as radians? Pi over 3 and 2 pi over 3. Does that make sense? Yes? All right. Let's try another one. Number 2. I'm going to let you guys try this one on your own. Cosine of theta equals negative root 2 over 2. Those of you that like it this way, you're good. Those of you that write it my way, or the way your teachers did last year, how do we write it? How do we write it? Root 2 over 2 is what? 1 over root 2. Should you know those are the same thing? Yes? All right. Get down to what two quadrants you're in, what's your reference angle, and figure out what it is. Anybody tell me what the reference angle is?
45.
45. Is that something we should know right away?
Yes.
1 over root 2 reference angle is 45. Okay, is 45 degrees one of my answers? No, why not? Because all students take calculus. Where is cosine negative?
Only
Is cosine negative up here?
No.
No. Is cosine negative here?
No.
No. So are these the only two places where cosine's negative? Yeah. So 45 is not one of my answers because 45 only happens if quadrant 1 is one of my quadrants, and it's not. So what is 45 in quadrant 3? 2, sorry, and 3. And what are they? 135 and 225. You either have those memorized or you do 180 minus 45 and 180 plus 45. And in radians, what is that? 3 pi over 4 and 5 pi over 4. I do want both sets of answers on homework tonight. I believe they asked for both sets, but on the test you only have to give me either those two answers or these two answers. Okay, let me give you number 3. Sine of theta equals 0. A little trickier than the last few, but try them. You guys are good at this. All right, go, 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 go. All right. Is this a special type of angle? I'm running out of time. Yes. Tonight's assignment is a book page, by the way. Is this a quadrantal? Yes. 0, 1, 0, negative 1. Is that right? No, it's not. 1, 0, negative 1, 0, 0, 1, and 0, negative 1. All right, sine is y. When is y 0? 0 and 180. Can I say 180 and 360?
Yes.
Ooh, can I? No, because we can't use the 360. Because it's not equal to, because it's the same as 0. So we say 0 and 180, which is 0 radians, and what's 180 degrees? Pi. All right. Do we have time for one more? No, I'm going to try it anyway. Tan of theta equals 1. Go, quickly. Anyone know your reference angle?
45.
45, good job. And then figure out which two quadrants you're in. For sure 1, because it's positive. What's the other quadrant? So you're just figuring out what's 45 in quadrant 1 and what's 45 in quadrant 3. And what do we have? 45 and 225. 225. You guys are awesome. Pi over 4 and 5 pi over 4.
Could you go a little more in depth on this one?
Yes. All right. Tangent. The tangent is only 1 when you're at your 45 degrees, because 1 over root 2 and 1 over root 2, when you divide them, is 1. So tangent is always 1 at 45. That's an easier one to memorize. See you guys. Enjoy your weekend. You memorize it. It's an easier one to memorize because they're the same. And when they're the same, it's 1. So that's why we said 45 here and 45 here.